Hello, this is Tyler Weaver, and in this episode, I'm making a response to episode 72 of ADSP. In this one, Bryce and Connor talk about C++ standard algorithms, and specifically, they take one problem and they talk about the different ways that an interview candidate might implement this problem using different standard algorithms. That would be interesting to actually just go and try to do the implementation in Godbolt and see if we learn anything. So um, here's Compiler Explorer. I'm going to include a set of headers I think I might need. Weird, the syntax. That's okay. All right. So the first one is just the most the problem I stated above, given a vector of integers by the two largest integers. The first is like the most naive algorithm you might use, and that's sort. So we're gonna start with that one. We want the two largest integers in a vector of integers. I call this two largest sort. So to sort, I first have to make a copy. So data really explicit what it is. Standard sort and data in, and then as this is the naive implementation, probably see somebody do something. There's our sort, and just to show you that it works, I'm gonna type up a really name here. We need something that creates vectors, so I'm gonna write something really quick I'm gonna use for testing. What I'm doing here is just trying to create a vector with a really consistent distribution, but that will have to, it's not like sorted in any particular way. Okay, so now I'm down in the main, I can use this thing. To make it easier, I must do this. Oh, I want FMT. Make it easier to print stuff. I misspell functional. Yeah. Files. compiling. All right, so there's our, our vector of data. All right, so I want to call this thing and print the result. Sort result. And I'm just doing this to show you that like each one of these gives the same result. Do it. Build. Assuming I didn't have another typo. I did add the FMT library ahead of time. We're building with 20 GCC. Okay, 35 and 37. Does that make sense to us? 35 and okay, yep. Two largest numbers. All right, so the next one that they talked about on the show using nth element. It's relatively trivial if you realize that you can pass a function object pass thing. Note we still have to copy again because we're gonna reorder this thing. All right, now calls int element and note we can't use the constant iterators because we are editing thing. And I don't know the rotate point. All right. Data.end. And I'm going to use that should allow me to those should be my two largest values correctly. Again, plus what is it upset? I do use the format document. Oh, okay. I actually didn't do anything wrong. It just taken a while. So we'll print these, make sure that this worked as we thought. That to compile while I work on the next one, and then that's nth. Max element. This is something that kind of came up at the end of the conversation as to like a naive way someone might do it, and I think this one is going to surprise you a little bit. So again, same function signature. Well, and in this one, we still need to make a copy because we're going to modify the vector again. So this time we're going to call the algorithm's function max element to get the iterator to the largest value. But we can use the constant iterators in this case. ADSP. data.cend. We need to save that value that it was. So do this. I'm gonna. All right. Now the trick is just to remove it and then call the same thing again. So data.race. Just this is why I needed the iterator. And then for the second one, I can just call the max element thing again and dereference the iterator. Back. All right, so yeah, second largest and then largest value. All right, and that should work. Values. Is it anything else? Not yet. It's taking its time to copy this. Make this Emacs. This is element. Came through good. It'll go ahead and compile that. Now we're getting into the like more confusing stuff, and we're gonna start with the one that I think it was Bryce that would be way simpler to implement, and that is with transform reduce. This is the one he kind of like held off for the longest time to say which one it was. This is a little less intuitive than the last, but it's not that bad. We have maybe the most difficult one for last. So again, start with the same function signature. But this time we're going to do transform reduce. So the first thing we got to do to make transform reduce work is we need to create an initial value. So I'm going to do this. We use make tuple for that because our values that we're tracking are going to be tuples. We're going to use the numeric limits of int min function to create a tuple of the two smallest integers, min. Really like this format document. All right, so we did that. Next thing we got to do is we got to come up with a transform operator. So the transform is the thing that's going to take a value from our vector and convert it into a tuple. So auto const form. I'm going to use a lambda for this. This is going to give me a tuple. It's all right. I'm going to say the first one again. The numeric limits of int and min. Int min type and the value that I passed in. All right, now we need a reduce operator, and this is like a little bit more confusing. The reduce operator is going to take two tuples and reduce it into a single tuple. And there's probably a better way to do this than what I'm going to do. Where if you know better how to do this, you should let me know. This is my best attempt at this. So this is also going to output a tuple, right? And how are we going to do this? So my best idea on how to do this is actually with a sort, which is probably the wrong idea. Best idea I have. I make an array of 4 elements and then use the positional get thing from the tuple to build this. This is like the ugliest part of this one is how this works. Okay, so now I have my array, 4 elements, 4 integers. And then I'm going to just call standard sort on that array. I imagine sorting a 4-element array should be really fast and really well optimized. And then it's just our last 2 elements that I need, 2 and right. Just 2 of that. All right, now we have our reduce operator. So now we can call transform reduce. Is it value? Yeah, values. We can use values. We didn't have to do a copy at this point. And we can use the constant iterators. All right, and that should work. Let me format. I'll copy this, and this is our transform reduce. Now for the reduce. The reduce is a little harder because you have to create a thing that has 4 different overloads on it. The reduce to work. That about my sort. What is it now? No matching function called the sort. Array 4 iterator. Oh. Not the function, it's the red. It is the function, not the actual iterator. There, that should compile. All right, the next one's going to be a lot harder and a bit more confusing. So, yep, see that works. Look at them. We're all still giving the same answer. This one's a little more confusing to write. We have to start by writing this thing that takes the this structure. So with a bunch of operator overloads in it. So I'm gonna just call this thing toLargest is what I'm gonna call it. And there's 2 of them that are like very similar. They're just it's like the value and then the tuple and then the tuple and the value. And so I'm just gonna write a single function to handle that case. I'm gonna call it toLargest off. And we'll see. So this is gonna take an int value and a tuple int. I'll do a reference to that, even though I'm not really sure whether it's faster to do the references for the tuple. It's something we can experiment with in a minute. So this is the one that's a little confusing to write. So if the value is greater than or equal to the second element in our tuple, which is the larger of the 2, we have a new largest value. So the second element of the tuple Then we want to shift. So we want to return the one that was the largest is now the second largest. Value. All right. Then we need to check to see if we have one that's large. We need to replace our second largest value. If val is greater than or equal to second largest value, which is stored in the first position, tuple. Then we're going to return the value and the we leave the largest value still alone. All right, and then if this wasn't bigger than either of them, we're just going to return the tuple. Yeah. So now we have this thing. Now we can start writing the various ones. The first one is that we need is the one that takes two values from the array. So all right, so now we need these to be in order, as lower and then higher. So if LHS is greater than RHS, we want to return a RHS, LHS, and then else LHS, left-hand side, and then right-hand side. Okay. All right. So that's our first one. Now, these are the two ones we just wrote that function for. Int. First one is going to take tuple int that tuple and a value. And we're going to call our function that we created up here, two largest op on the value and the tuple. And then we have basically a copy of this with the order of the parameters switched. So value comes first. All right. Now the last one, which you've already seen. It's the reduction when you take two tuples and turn it into one tuple. So that's tuple int. So we've already written this one. We can come grab it from here. It is that this thing right here. Reduction. There we go. All right. Semicolon at the end of our struct. And we have our struct. All right, now we can write the reduced version, which is really easy to write now that we have that operator. We still need that similar init value. Right, minimum value. All right, then we can just call reduce. We can use constant iterators again. Init, and then our struct we created. This. And that should work. Here's just the reduce version. This should compile. See what else I got wrong. Oh. 59. Oh. Couple. Yep. So you'll see I'm taking const references to these tuples, and I'm not sure if that's good or bad. Like, does it make more sense to copy the things? It's kind of it's a trivial data type. It's int and int, so it shouldn't be that bad. You'll see they all return the same thing. And now for the kind of surprising part. And the surprising part is that I have Quick Bench locally on my machine. I've run it with all of these with varying input vector sizes. And what's really, you probably already predicted, the largest, two largest, the sort one is pretty bad. So we knew that was going to happen. The next in my test is the transform reduce. And the best one is the max element one. And if I continue to increase the size of these vectors, they just it just continues out in a similar way. It's really kind of confusing to me. I wonder if there's something I did wrong about implementing them. I really expected the reduce and transform reduce to be the smaller ones. Those are these two, and not nth element and max element. But apparently max element and nth element really well implemented. There's also the exercise of maybe using the parallel versions of these. I will leave that to the viewer to go try that. Thank you for watching. I hope this has been fun looking at the standard algorithms library and how you might use it to solve one of these problems. C++ is a wonderful language and has these wonderful tools, and it's really cool to spend some time just playing with them. I encourage you to go take any one of these sort of resume, or not resume, but interview questions, and go and implement them with various algorithms. It's a great way to teach yourself more about the various algorithms and when you might use them and how they interact. Thank you for watching.